At its heart, Python is one of the most powerful calculators on the planet. But here's the thing, if you don't know its most important secret, this one single rule that controls all of its math, you're going to get the wrong answer every single time. So today, we're going to uncover that rule. So here's what we're going to do. We'll start with Python's secret math rule, then we'll decode this simple little acronym that explains everything. After that, we'll see it in action. Then, and this is the fun part, we'll build a practical BMI calculator to show just how useful this is. And finally, we'll talk about what you can build next. So why are there these strict rules in the first place? Well, it's because Python isn't guessing what you mean. It's following a super precise order for every single calculation. If you don't know that order, your code might run, sure, no errors, but it'll spit out the wrong results. Understanding this is really the first step to writing code you can actually trust. To see exactly what I mean, just take a look at this expression. 3 times 3 plus 3 divided by 3 minus 3. Now, Python says the answer is 3.0, but how? I mean, that might not be the answer you'd expect just looking at it. And this little puzzle is exactly what we're here to solve. Okay, so the secret to cracking that puzzle lies in a simple acronym you might have heard of before, PEMDAS. The easiest way to think about it is like the grammar for Python's mathematical language. It is the rulebook that Python follows religiously, which makes sure every calculation is consistent and predictable. This whole concept has a formal name, of course, the order of operations. And this isn't just a Python thing. It's a universal standard in pretty much all of mathematics and programming. It's the reason why, no matter who writes the code or where it's run, the same equation will always give you the same answer. Let's break down exactly what PEMDAS stands for. P is for parentheses. Python always tackles what's inside them first, no exceptions. E is for exponents, which in Python you write with a double asterisk. Now here's a really crucial detail. Multiplication and division are on the same level of priority. Python just works through them from left to right as it sees them. The exact same thing is true for the last step, addition and subtraction. Okay, we've got the rules down. Now, let's pretend we're the computer for a second and use PEMDAS to solve that puzzle from the beginning, step by step. First up, Python hits the parentheses, 3 plus 3 becomes 6. Our expression is already simpler. Next, our multiplication and division. And remember, we go from left to right. So 3 times 6 is 18. Then 18 divided by 3 gives us 6.0. And hey, notice that Python adds that decimal point? It turns the number into what's called a float, because division in Python is designed to be super precise. And finally, the last operation. 6.0 minus 3 leaves us with 3.0. Puzzle solved. So the really important thing to get here is this. PEMDAS isn't just some random rule. It's the system that guarantees your code is going to produce reliable, predictable, and correct results. Without it, programming any kind of complex calculation would just be chaos. All right, enough with the abstract math problems. Let's take this concept and put it to work in the real world. We're going to build a simple but really useful tool, a body mass index, or BMI calculator. So this is the standard formula for BMI. It's just a person's weight in kilograms divided by the square of their height in meters. It looks pretty simple, right? But PEMDAS is doing some serious heavy lifting behind the scenes here. Let's walk through why PEMDAS is so critical for this to work. Python sees the parentheses and knows it has to evaluate height squared first. That's the E for exponents in PEMDAS. Only after it has that result does it perform the final division. I mean, think about it. If it just went left to right without any rules, it would divide the weight by the height before squaring, and that would give you a completely wrong answer. And once you have that BMI number, this table is what gives it context. It just shows the standard categories, all the way from underweight to obese. See? This is how a simple calculation, as long as it's done correctly, can provide some pretty meaningful information. And just like that, you've connected a fundamental programming rule to a practical, real-world application. By understanding the order of operations, you now have the foundational knowledge you need to build a useful health tool, or really any tool that involves calculations. So, we've covered the rule, we've seen it in action, and we've built a real-world example. Really, the only thing left to do is to think about what comes next for you. When you boil it all down, it really comes to this. By mastering this one core rule, you unlock the ability to perform countless calculations correctly. And this isn't just for puzzles. It's the foundation for code in finance, science, data analysis, you name it. So I'll just leave you with this question. Now that you understand the rules that govern Python's incredible built-in calculator, what are you going to build? A mortgage calculator? A tool for a science experiment? The possibilities, and I mean this, are truly endless.